Okay, this is a continuation of the practice test for MAC 1140 Pre-Calculus, exam number 1, covering appendices 3, 4, and sections 4, 5 through 4, 7. We're on problem number 29. Numbers 29 through 35 is from section 4.5. And so in number 29, we have an inequality, x squared minus 2x minus 15, and we're looking for a way to find the solutions of this inequality and give the answer in interval notation. So anything that is second degree or higher in an inequality, you're looking to find the cut points. And so what the cut points come from is just temporarily, think of this as an equation. So this will be step 1. We'll just temporarily think of this as an equation rather than an inequality. And the cut points are nothing more than what we call the zeros. Zeros is another name for the solutions. They mean the same thing. So what we do when we are, oops, I wrote x cubed here rather than x squared. Let me fix that. So when we're solving a second degree equation, one of the most common ways is to factor it. Take the square root, and that's why we concentrate so much on factoring, because it is so much a part of many procedures that are in algebra. So we break up the x squared, and since the leading coefficient is 1, all you need to do is 2 steps. No need for splitting the middle term, which is 4 and 5 steps. Just think of 2 numbers that multiply together to give you negative 15, but those numbers should also add together to give you negative 2. So 5 times 3 would work if we put a negative on one of them. So we want, when we add them, to be negative 2, so you want the bigger number to be negative. You got to get those right or the solutions come out wrong. Okay, so this times this is negative 15, this plus this is negative 2, so those are the proper numbers with the proper signs. Negative 5 and positive 3. So when I say what are the zeros of this particular equation, it's the number that creates a 0 right in here. Plugging in a 5, a positive 5 would create a 0 because you go 5 minus 5 and get a 0. What would create a 0 right in here is negative 3. Those are your zeros, and in these particular problems, they are also known as the cut points. The zeros are the cut points. They take your number line and they cut it up into various intervals. The negative 3 would be furthest to the left, and then the 5 would be further to the right. There's no need to put anything on this number line other than your cut points. Okay, so we tossed those cut points onto the number line, which were just the zeros of the equation. And now what you're going to do is test each of the intervals. So now you need what are called test points, because they are numbers that you have chosen in each of these 3 intervals, because the number line has been cut up into this interval to the left, this interval in the middle, this interval to the right. And you want to test whether the numbers in each interval work or not. And so you choose one number from each interval. I would say stay as close as you can to the actual cut points, because otherwise the numbers get real big and then you have to plug them in. Use zeros wherever possible if you're in an interval where there's a 0 available. So I think what I'm going to do is test negative 4 to represent this interval. In between negative 3 and 5 is the number 0. So I'm going to test 0 to represent that middle interval. And I'm going to test 6 to represent this interval. Okay, so my test points are going to be negative 4, 0, and 6. Okay, you're going to plug that into the original inequality. Asking yourself, does the test point, after you perform these upper operations, come out to be less than or equal to 0? Okay, so first number, And you can just keep reusing this if you want, just erase them. That's why it's good to work in pencil. So first I'm going to plug in -4. I'm just going to keep rewriting it so you have all of my work. So this will be 16 plus 8 minus 15. Is that less than 0? That's what you're asking yourself. So 16 plus 8, that's 24 minus 15. So you get a 9 here, and that most definitely is not less than or equal to 0. So no, this does not work. If -4 didn't work, none of the numbers in this interval work with respect to being a solution to this inequality. Next, I'm going to test 0. So here I was testing -4. Then I'm going to test 0. Okay, so it will be 0 squared, because it was x squared minus 2 times 0. I'm just plugging them into the original inequality. Minus 15, is that less than or equal to 0? So it would be 0 here, 0 here. All you'd have left is the -15, because this zeroes out, this zeroes out. And that is, any negative is less than 0. So yes, everything in this particular interval works. So we know that this is part of the solution set. And then we go on to the last test point, which is 6. So now we're going to test 6 in the original inequality. And figure out whether or not that's less than or equal to 0. So we have 36 minus 12 minus 15. So this would be 36 minus 12 is 24 minus 15. And 24 minus 15 is 9. And that's not less than 0. So a big no on that. So the only answers that actually work for this particular inequality is anything from -3 to -5. So final solution is everything from -3 to 5. Now you want to look at your original inequality to see if there was a partial equal sign in the problem, and there was. This was less than or equal, because that means that you're going to be throwing brackets around these endpoints rather than soft parentheses. You would use parentheses if there was no equal sign there, if it was just a plain less than sign or a plain greater than sign. So everything from -3 to 5, including the endpoints, -3 and 5, everything right in here works as far as a solution. So on the number line, you can show a picture of all the numbers that work. And then here you are stating the solution numerically rather than graphically. Okay, so that is for number 29. Everything from -3 to -5. Okay, then moving to next problem, which is 30. And in problem number 30, you have x squared plus 3x minus 4. Wanting to know where that's greater than 0. So first thing we're going to do is treat this as an equation. We're going to factor it to find the zeros and thus the cut points. Okay, so +4 times -1. It doesn't matter which parenthesis you put the +4 and which one you put the -1 in. But this times this is -4. That plus that is 3. So it's factored properly. So what would zero this out would be +1. Okay, if you plugged a +1 in there, it would zero out the first factor. If you put a -4 in here, then it's going to zero out this factor. So these are the zeros, which are also what we refer to as the cut points. Okay, so we come on this number line. Oops. Crooked there. It's a little bit better. Okay, so we can put -4 down here and maybe +1 over here, and then pick some numbers to test. On this side, I would test -5. In between here and here, I would test 0, and over here I'm going to test 2. Okay, so the original x squared plus 3x minus 4, and we're looking for when is it greater than 0. Okay, first number I'm trying is -5, and that would be 25 minus 15 minus 4. So 25 minus 15 is 10. 10 take away 4 is 6. That is greater than 0. Okay, and let's just check that out again. 3 times -5 is -15. 25 minus 15 is 10. 10 take away 4 is 6. So yes, right here. And typically the intervals alternate with respect to yes, no, yes, no. In other words, which intervals have numbers that work, unless you have zeros that have a multiplicity. And when we get to those, I will. That's why I think you should just stick to actually testing each interval rather than looking for shortcuts on the alternating of the yeses and the nos. Okay, so we know that everything in here works, and then we're going to go to the next interval where we're testing 0, which is the easiest one because it gets rid of a lot of the terms. So if we were going to, like here I was testing -5, here I'm testing 0, so it's 0 squared plus 3 times 0 minus 4. Is that greater than 0? That's gone, that's gone. Only number that's here is -4, and that is not true. So that's a no right there. And then we're going to test the number 2. So that would be 2 squared plus 3 times 2 minus 4. We want to know, is that greater than 0? So this would be 4 plus 6 minus 4. So 4 minus 4 is 0. Those cancel each other out, leaving you with 6 on this side, and that is greater than 0. So yes, here as well. Okay, so now you want to talk about two separate intervals, two intervals where there are actually solutions, but separated by an interval where there are no solutions. So what you're going to have to do is join these two solutions by a union symbol. So basically what you're going to be saying is any number from here, and I'm using soft parentheses because there is no little equal sign in this inequality. So when there's no partial equal sign, you use parentheses on your endpoints. And then you want to say that anything in this region all the way out to -infinity, anything from here to here is a solution. So when you are actually listing your solutions in interval notation, you read the solutions left to right so that you are giving the answers from smallest to biggest. That's one of the rules for interval notation. So final solution. Okay, here's part of it. Anything from -infinity up to but not including -4 is a solution. So solutions are all in here, or is represented by a union symbol in mathematics. Or you can also find solutions anywhere from 1 to infinity. So 1 to infinity. So when you see that you have two solution intervals separated by an interval that does not have any solutions, in order to make yourself jump over the interval that doesn't contain any solutions, you have to use that or symbol. These are disjointed solution intervals. Okay, so that is the final answer right there. Okay, moving on to number 31. So on problem 31, we start off with 4x squared minus 25 is less than negative 15x. This needs to be zeroed out before you can go on with the problem, just as numbers 29 and 30 were. So you're going to think of this as 4x squared. We're going to bring this over to this side where the 4x squared and the negative 25 is. We'll go second degree term, bringing this over as our first degree term, but now it's going to be positive because it's jumping from the right side of the inequality over to the left side. Same thing as adding 15x, adding 15x. And then we'll scoot that negative 25 out as our third term. So everything's over here. Nothing remains on this side because it went over to the left. So the symbol is still as it is, but it's zeroed out. We temporarily think of this as an equation, so that we can go about the business of factoring it, so that we can find the zeros, which are the cut points. Okay, so we went into a bunch of this where when the leading coefficient is bigger than 1 and you can't factor out any numbers to make these smaller, that you're going to go with splitting the middle term to get this factored. Okay, so here we go with that. We're looking for two numbers that multiply together to give us the A times C value. Okay, so we're looking for something that multiplies to give us negative 100, but adds to give us 15. All right, so let's see. Times 5 is negative 100. Okay, things that go into so 20 and 5. So we can make this negative and the 20 positive. 20 times negative 5 is negative 100. 20 plus negative 5 really makes us do 20 minus 5, and that gives us a 15 because we're adding two numbers that one's negative. Okay, those will help us split the middle term so that this becomes 4x squared, and instead of 15x, it'll be 20x minus 5x. I'm using these numbers but with x's on them, and then there was also a negative 25 there. Still trying to factor this thing. I just used these numbers to split the middle term. Then I'm going to factor these two terms together because now we have moved on to factor by grouping. I'm going to take a 4x out of these two terms because it is common to both terms. 4x times x would give you the 4x squared back. 4x times positive 5 would give you the 20x back. Then I'm going to move to the back two terms, taking out negative 5, putting the parenthesis here. Negative 5 times x would give you the negative 5x. Negative 5 times positive 5 would give you the negative 25. Almost there. So now what this term and this term have in common is x plus 5, and then what goes in the other parenthesis is 4x minus 5. Okay, so it's all factored. Now I want to know what would zero this out. In this case, it's easy to just look at this and tell it's negative 5. So zeros are negative 5. That's what would zero out this first factor. This one's a little harder to tell because of the 4. It's not just a plain x, so you might want to think about, all right, what would make this 0? Well, set it equal to 0 and solve it like an equation if you need to, if you can't tell what it is just in your head. Some students are good with fractions, most not, so you might want to just say, okay, what makes this 0? Set it equal to 0, and then solve it like a little equation. before x equal to 5. If you brought this negative 5 over here, then you would divide by 4, and you would get that 5/4 is what would zero that out. Okay, whatever makes this expression right here equal to 0 is what zeroes it out. So negative 5 as well as 5/4 would be considered zeros, which are really the cut points on your number line. So divide your number line up into intervals. Okay, so we'll put the negative 5 down here. And we'll put the 1 1/4 or 5/4 here. Okay, I'm going to test -6 to represent this region. Passing from any negative to a positive, 0 has to occur in that interval. So I'll test 0 here. This is 1 1/4, so I'll test the number 2 because I certainly don't want to test fractions. Okay, as I test these numbers, just as you've seen me doing numbers 29 and 30, you're testing it in the original inequality. So it's 4 times x squared minus 25, and you want to know if that comes out less than -15 times x. Okay, so one of the numbers I'm testing is -6. And I can get some help with that. -6 squared would be 36. 36 times 4 is 144 minus 25 is 119. Is that less than this times this? 15 times 6. -15 times -6 is 19. Is 119 less than 90? Nope. Okay, so that is no. Everything in this interval does not work. Okay, testing a 0. Again, using the original inequality, which would be 4 times x squared minus 25. Is that less than -15 times the 0 that we are presently testing? So 0 squared is 0. 0 times 4 is 0. 0 take away 25, -25. Is that excuse the barking. Dog's gone crazy. Dog's gone wild. All right, so let's see. -25 is that less than 0? Yes. Okay, so that's yes right in there. That's one of the intervals. Okay, last number that we're going to test is 2. So this is going to be 4 times 2 squared minus 25. We want to know if that's going to be less than -15 times 2. Okay, so this is going to be 4 times 4 is 16. Take away 25, which is -9. And we want to know, is -9 less than -30? No, it is not. Because when you're comparing two negatives, the one that's furthest to the left on the number line, that's the one that's the smaller value. So this is not smaller than this. So this is no. So the only ones that work for your final solution here is the region in the middle, the interval in the middle, which is everything from -5 to 5/4. Whether or not we're going to actually include those two endpoints is dependent on whether there is a little partial equal sign in the inequality, and there isn't. Okay, so for this one, we're going to say that everything from here to here works. From -5 to 5/4. And let me just check that real quick. That's number 31, which is D. Perfect. Okay, moving on to 32. Okay, let's see, let me copy 32. Let's try that one. Okay, here it is. Okay, so this is 25x squared plus 81 is less than 90x. You're looking at the same thing here where you have some terms that are on the right, some terms that are on the left. You're going to want to bring this over here so that it reads 25x squared minus 90x plus 81. All less than 0. So zero it out. At that point, you can create the temporary equation. Okay, these numbers are pretty big, and I noticed that both of these ends have a square root, a perfect square root. So if I can factor this by way of figuring out whether this is a perfect square trinomial, I'm going to factor it by that shortcut. Let me check it out real quick. If I was to take, and right now we're thinking of it as an equation. If I was to take the square root of this term right here, it would be 5x. If I was to take the square root of this term, it would be 9. When you multiply these together, you get when you multiply those two together, you get 45x, and then when you multiply it by 2, you get 90x. Perfect. This is a perfect square trinomial, and so just in finding those square roots, you've also really factored it. All perfect square trinomials factor like this. Just those square roots are what goes in the front as well as the back. And then the sign that joins the two terms, just look at that linear term. That is the sign that you should have right in here with a square. Okay, so this side, all factored, is 5x minus 9 squared equal to 0. Okay, so now when you go to factor these, give me 1 second. Okay, so both of these factors are the same. The same thing as 5x minus 9 times 5x minus 9. So knowing what zeros one of them out is the same as what zeros the other one out. Okay, so what makes this 0? Well, if you can't tell just by looking at it, then set it equal to 0. And you'll have 5x is equal to, just solve it like a little equation. Divide by 5, divide by 5. Problems like this is why I want you to, instead of using the shortcut of just thinking, okay, the yeses and the nos always alternate, in certain situations where a factor has a multiplicity higher than 1. Multiplicity refers to this power, meaning a repeating factor. And whenever that enters the situation, it derails that alternating yes-no pattern. So I would say just make sure that you're testing each and every interval when you go to decide whether the interval produces solutions or not. So this is the 0. This is the number that when plugged right in here, it would zero out this factor, and therefore it's a cut point. Okay, so that means your number line is cut up by just one number, 9/5. And you need to check what's going on, the interval to the left as well as the interval to the right. So let's see. 9/5 is the same thing as 1 4/5. So over here on the left where the smaller number is, you could test the number 1 because 1 occurs in here and then you get to 1 4/5. After 1 4/5, the next biggest whole number would be the number 2, so I'll test the number 2. over here. Okay, this number 1 represents all numbers to the left of 9/5. This test value of 2 represents all the numbers to the right, on the right of 1 4/5. Okay, you're plugging it into the original inequality, so that's 25x squared plus 81 is less than 90 times x. Right now I'm testing the number 1. Okay, so this would be 1 times 25. 25 plus 81 is 106. And then 106, and we got a 90 over here. This is a false statement. 106 is not less than 90. So that's a no. Nothing over here works. And now we're going to use our other test value of 2. So once again, go back to the original inequality. That's 25. This time you're plugging in the number 2 squared plus 81, wanting to know if that's less than 90 times your x value, which again is 2. So this will be 4. 2 squared is 4. 4 times 25 is 100. 100 plus 81 is 181. And then 90 times 2 is 180. And again, you have another false statement. So nothing over here works either. And if nothing works over here and nothing works over here, and the cut point doesn't work because this doesn't have an equal sign. So that endpoint is not included in the solution set. So that means nothing on this entire number line works. And therefore you're in a case where there is no solution. No values on the entire number line work. Okay, that takes you all the way up through number 22. Okay, that's all I'm going to do for this video. So I will jump in with numbers 33 in the next video, 33 and on in the next video.